Welcome everyone. This is our episode club. If you haven't been here before, we talk about the science behind science fiction episodes that we have that our patrons have suggested and voted on. And Andy, thanks Andy. That was what that was. Andy. Super DTG. I appreciate the support. That means a lot. But yeah, so this week, thanks to Super DTG suggesting these episodes, we are going to be talking about Stargate SG-1. We're going to be talking about Season 4, Episode 6, Window of Opportunity, and Season 4, Episode 12, Tangent. I'm not going to lie, when we've done Stargate before, I've mentioned this in the past, that my Stargate knowledge is lacking. I have seen a lot of them, but the thread, the lore, and all of that is lacking. So when we get to Tangent, I am going to need... I know. Agreed. Okay. Thanks, Mafo. I appreciate you being here. And physics, I know. I'm being shamed by physics. Story of my life. All right. So when we get to Tangent and we're talking about like the wars, and I can deal with the technology stuff. The lore side, I'm going to need some feedback on. But that's why you're here. That's why we're all here. But let's start out with Window of Opportunity. Again, Season 4, Episode 6. This one, I mean, I've seen this one a couple times. This is a great episode. I think from feedback from people, this is one where it brought a lot of people into Stargate, or it's one of their favorite episodes. And essentially what happens is they're going, exploring a planet, and I did forget to do this. Character names. Because I'm terrible with this stuff. All right. Fix that. Oh, no worries, domestic. Announcement. We are going to have this episode club, 2 more episode clubs, then we are retiring the episode clubs. But you can find the links. In fact, let me throw the link in there so people can find it and go to it. Oh, excuse me. So just the things that are changing for the patron page, and what streams we're going to be doing for various reasons, but just know that I love all of you and I appreciate all of the support that we get. But yes, Window of Opportunity. They are at this planet, and there's essentially a high amount of solar activity, particularly CMEs, or Coronal Mass Ejections, as was pointed out by Sam multiple times, which we appreciate. What they do, they're essentially giant solar flares that disrupt the geomagnetic field and increases the radiation to the surface. That's from the dialogue, and also the definition of a coronal mass ejection. So, fabulous. I also really like at the beginning where he was looking at the sun. He has sunglasses on, and then he's actually looking at it like with an extra filter. Smart. Never look directly at the sun. So I appreciated that thoroughly. They have this creepy dude there, this, ancient alien archaeologist guy there, that, named Malachi. And, he basically turns against Daniel and, throws him aside, and then they get zapped, with the radiation stuff. Teal'c. I never say that right. Teal'c and O'Neill get zapped, and they get thrown back. And they're sitting in the commissary. I know. Teal'c. Thanks. Every time, it's like I hear it on the show, and I'm like, oh yeah, okay, I got it. And then I write it down as it's spelled there, and then how it's pronounced on the show versus how it's spelled disappears out of my brain. So, Teal'c. I know. I'm sorry, Ryak. I'm sorry. All of the support. I love him. I'll get it eventually. I'll get it. It doesn't, in my own defense too, they don't exactly stay consistent with it. So I appreciate it. But yeah, they get thrown back. They're in the commissary, and it's effectively like the day of this mission that they get, or the day before, 10 hours prior to their mission getting there. And I love it. So they're trying to figure out what's going on, because they're reliving the day. They're like, yeah, this is, I'm back, and we haven't gone on our mission yet. And I remember learning about coronal mass ejections, and I shouldn't know that before. And I think at one point even Sam is just like, O'Neill used coronal mass ejection and geomagnetics correctly, so something is up here, and I thoroughly appreciate that. But there's a lot of solar activity. We're on planet P4X639, which I did catch that. And yeah, maybe he read it in your report. The interesting thing that I did like is that when we've talked about time travel and we've talked about time loop episodes, Asdelin, we're talking about the Groundhog Day episode. When they go through these. Now, before we knew it was a Groundhog Day episode, and they've just been thrown back in time briefly to 10 hours prior to their mission, we're still, as viewers, not sure what's happening, right? Is this predestination? Is this... From all of the time travel that we've learned from doing all of this episode clubs, there's lots of different types of time travel out there. So, they do learn that they postpone the mission. I mean, they straight up say, they're like, something's weird. We've been here before. We know what's going on. Everyone's like, okay, let's postpone the mission. Let's figure this out. And then it all changes from then on. He's like, well, we've changed the future because we should have been on the planet already. So I can't predict what you're going to say. And then zap, and they get thrown back again. So whatever. Oh, Asdelin, fangirl all you want. This is where it's at. So this zapping, this frying that's happening on the planet P4X is still affecting them whether they're there or not. So this is very much a Groundhog Day episode. And in fact, is that the movie? I was going to look up the movie that just came out with... I can't remember the actor or the name. That came out on Hulu called Palm Springs. It might have just come out. Tenet? Not Tenet. That's not out yet. But Palm Springs, Groundhog Day style film. Really good. Really good. Very similar to this. Yes, thank you. We got there. So yeah, Palm Springs, very similar to this. Even to the extent where it's like they lose track of how many loops that they've done. And they are trying to... that they've just reached that, like, yeah, I don't care anymore because nothing I do is valid. Yeah, Andy Samberg, that was the name I was trying to remember. Physics. So what is going on? And that's what I did like. So that's kind of the direction I was going there, is that in these other Groundhog Day ones, the person who is, Jason, bad example. The people who are stuck in the loop, in Palm Springs or Groundhog Day, they don't know how much time has passed that they've been looping these in. But in this episode, we do actually find out, at least we have a minimum. We have a bare minimum that they have. And yeah, Asdelin, someone did calculate that it was like dozens of years at least. And yeah, in Maloric, that was, bad example. But one of the things that I like is that once they break the loop, then as mentioned, they get back out and they say the Tok'ra had been trying to reach them for 3 months. And what it was they were stuck in this bubble that had, about a dozen star systems that were all kind of circularly-ish placed, with the central being this planet P4X. And so it kind of had this bubble. They realize that this is an Ancient One structure. They try to figure out how this is being done, what this effect that this is having. And they realize that this bubble that they've created that's causing them to be stuck in a time loop has taken like these planets out of sync with everyone else. And it's creating... So the way they phrased it is that the device has a simultaneous connection to the rest of these star systems, creating a subspace bubble that's isolated from time. And I agree, Jason, very much so. And the magic CME radiotherapy class. So they say subspace a lot here. And remember what subspace actually is. We have a trampoline of our sheet of space-time, 4-dimensional space-time. Subspace is this idea above or below that. It's the outside of the trampoline. That's subspace. Now, it could be higher dimensions. It could be, whether it's string theory, whatever you want to do for that. That's what subspace is. And I mean, they use it correctly in Stargate when they're talking about the wormholes and how they're connecting these 2 points in space and time, and that the wormholes that the Stargates create punch through subspace. And amazing, I have it on the notes here. So the beam's access to the gate's subspace field creates a time inversion outside of subspace. And yes, D Starfire, exactly. Thanks, Aslan. That they are basically warping time, but it's connecting a whole bunch of points. So there's a concept when it comes to cosmology and space-time about how our universe is shaped. Some of you may have heard of or seen this before, but the idea that our universe is a closed universe, a flat universe, or an open universe. Oh, thank you, Iso Hunter. And as far as we know, it's flat. That our universe, not Earth. Earth is round. But the universe, as far as we know, appears flat. But part of cosmology is trying to figure out, does it actually have a much bigger curvature on a large scale that we're just too small to actually see? Thank you. And but one of the ideas with a closed universe, hi, I'm glad you like the Janeway chip. I'm very proud of that. One of the things that I like with this closed universe idea is that a closed universe is spherical on multi-dimensions, but it's closed, so it's spherical. And you could, in theory, kind of have a loop, that if you traveled in one direction long enough, you would loop back to a point back in space and time. It's very broad way to think about it. Cosmology is a little bit more complicated than that, but general idea of a closed universe. And that's kind of what they created here. So what the ancients did when they tried to go back in time, save, their civilization and all of that, they created this bubble of subspace with this device that utilized the geomagnetic storms, which we'll get to permeate this bubble. And that bubble, if you think about it, so let's kind of try to conceptualize this a little bit. And let me see if I missed. Thanks, D Starfire. Yeah, the open is the saddle shape. But what they tried to do is, let's imagine we have our flat sheet of our universe. What they did is that they punched this bubble into it that isolated it, but then they're living on the surface inside of that bubble. So they've kind of punched it up. Now we have this bubble, and that's that cycle that they're going through. That's kind of how I saw it. And then what they need to do is they need to disrupt that to keep that bubble from forming. Because every time they come back around, that's where that storm is happening. Now, the way I kind of interpreted the fact that it was like a recurring thing that happened, is that the geomagnetic storm and the coronal mass ejections, and Iso Hunter, I saw your question, I'll get to that in a second, and physics, yeah, that's kind of what I'm talking about, that works. That, remember, if you've been here before, if you haven't, that's okay, in order to warp space-time, whether you want to build a warp drive, a warp bubble, or you want to, if you want to play with space-time, you're going to need mass. If you don't have mass, you can use an equivalent amount of energy. Now here, what they're doing is they're basically saying that the coronal mass ejection and these massive solar flares that happen are bringing in the energy that allows them to create the subspace bubble. Now, we can imagine that maybe over time it just it's not able to sustain itself, so it flattens out, and then we go back to normal time, and then in 50 so years, I think they talked about, it happens again, or it can happen again, that they're able to utilize this this technology to channel the energy to build the bubble of space-time again. They're trying to go back in time, so they're trying to connect. What they're trying to do, they're here, they want to go to here. They're trying to bend space-time so they can get over there. But what they do instead is they build a bubble. They build a circle, and then they get trapped in it. So that's kind of how I perceive the science explanation of this time loop that they're actually stuck in. So Eyes of a Hunter, kind of yes. So I can throw this in here if this works. Yes, there we go. So that's a little bit about my background, but yeah, from the eyes of an theoretical astrophysicist, how the science in these sci-fi episodes should maybe work. Now, physics pulled out the Alcubierre drive. Yeah, that's kind of what they were doing. That instead of building a jump drive, remember jump drives bend points in space and time, they accidentally built a warp bubble and then they got stuck in it. So that I think makes sense. And it was causal, but it's both spatial as well as temporal. And that's what I liked about this, because this concept of space-time, and yeah, Eyes of a Hunter, go for it. We jump all over the place here, so feel free to throw a question and I'll try to tie it to Stargate, but if you have a random question, that's okay too. Now, this bubble that they created exists both in space and time. They're continually living through it. They didn't really go into like why Teal'c and O'Neill are the only ones able to remember it. It had something to do with getting actually zapped by it. But regardless, this device was activated due to the energy source of the coronal mass ejection and the geomagnetic storms. Activated the device, punched up this bubble, created this bubble in space-time that they then got trapped in. And they have to they basically have to reach the point where they go around again and not activate the device and just say, we're done. And then it flattens out. So yeah, thank you. Yeah, a piece of paper would help a visualization of this. Do I have any? I have the paper that I used that I built our world lines for All Good Things last weekend. All right. Space and time. They're here. The ancient ones were trying to go back in time to change their timeline. They tried to do that. They used energy. They were going to use energy from the CMEs and the geomagnetic storms to go back in time. But it didn't work, and it ended up doing that, but on a much smaller scale. Does that help? I can probably do that. So, yes, I think that works. And I like it. The other thing that I really like is the fact that they were using the energy from the solar activity, because solar activity is a very periodic thing and has to do with the fact that we have a spinning ball of plasma. Like, for example, our star goes through these solar cycles of approximately 11 years, but that has to do with the size and the mass and the rotation rate of our star. So it goes through these cycles, but those cycles are determined by the size and the rotation rate of it. But any spinning ball of plasma is gonna go through these. So I was gonna talk briefly about what solar flares or coronal mass and what coronal mass ejections are. And physics just said, do the event horizon wormhole explanation. If we have time, sure. I've also put event horizon on our patrons voting page for a long time, and no one votes for it because we're all scared of event horizon. We're all terrified of it. Yeah, so good times. But anyway, so CMEs, solar flares, solar cycle. Our star is a spinning ball of plasma, and then as this ball of plasma is spinning, there's a lot of magnetic activity here as well. And because we have ionized gas. Plasma is like this fourth state of matter, right? You have solid, liquid, gas, and then if you heat up the gas enough, it ionizes, and you get what we call as a plasma. because a plasma is ionized, that means that we've stripped the electrons from the nucleus. So nucleus is positively charged, electrons are negatively charged. Once we have this ionized plasma, there's a lot of magnetic activity because we have almost like these free charges just floating around. So you have this ball of plasma that's spinning, and as it's spinning, it builds up these magnetic fields because you're going to get a pattern, a cyclical pattern to the motion of the material of the star. Now, as that's happening, because it's not a solid ball, we have this angular rotation rate is going to be different if you're on the equator or if you're on the pole. And because of that, we start to get these charges build up. That basically, the best analogy that I think still holds up is to twist up a rubber band. That's kind of the best way to think about it. And as you start to twist it up, it's going to get more and more tense, and it will eventually burst. And that's kind of what happens to the magnetic fields on the sun. So as the sun is spinning, we have these differing rotation rates because it's not solid. The differing rotation rates and these charged particles will create poles. They basically create what are called sunspots. And sunspots are essentially magnets, like poles of the magnets. And you can see, if you've seen pictures of the surface of the sun, you have those like filaments that look like if you stuck a magnet into iron filaments, and you see that. That's what's happening on the sun with these sunspots. And those are formed from this ball of plasma that's spinning. But because it's continuing to spin, they continue to increase. And like that rubber band, they start to spin up and they start to increase in their tension. And then they burst. When they burst, we get solar flares or coronal mass ejections. And coronal mass ejections are essentially solar flares. So solar flares tend to be this big burst of some radiation particles, some like actual charged particles, but it's mostly in the X-ray or ultraviolet light. So you're just getting this big burst of light as this discharges. But a coronal mass ejection is a huge event. So this is when you have those big threads that have built up, and you have these charged particles that are actually present in that trapped environment. And when that bursts, those particles go flying. That's why we call it a coronal mass ejection, because it's actually a lot of massive particles that are flying out of the sun and hopefully not hitting Earth, because bad things happen when that does. That was the Carrington event from the 1800s, was a coronal mass ejection that destroyed the old ways of communicating, pre-phone. Telegraph. Thank you, Real Retox. Yay. The telegraph system. They fried the telegraph system. There are rumors that telegraph operators, when the Carrington event happened, got shocked through it. Telegraph paper caught on fire because you just had this huge surge of energy that went through all of our power systems. And what limited power we had in sort of, what was it, 1870s, I think? I think it was the 1870s or 1880s. Bad things happened. So coronal mass ejections do happen. They are not as common as solar flares. It's a similar activity that's happening. It's just this is a much more intense one, and it's slightly different. And thanks for the follow. I appreciate that. And thanks for it's on brand for the team. The team, everyone present here has to fill in my names of stuff because I am terrible at doing that. So I'm just kind of scrolling back a little bit here into some of the questions. Physics asked, are electrons in the plasma stable? That's a really good question. So we do get some activity of these electrons. Oh, God, what is it? It's this type of radiation starts with a C that I can't remember the name of. But it's essentially when you have these charged electrons are flying by at high speeds, Cherenkov radiation. See, that was a hard one. I don't feel bad about missing that. But yes, Cherenkov radiation. We do get some of that from the sun, but this is why we have solar physicists, is that they're literally observing exactly what you're asking. How many, what's the stability of the material in the sun? That's still It's not a total unknown, but it's still something that's being studied. So Eyes of a Hunter asked a really good question. And thank you. Oh, and thank you, Andrew. Yay. So Eyes of a Hunter asked a really good generic question, but traveling from one star to another really fast, it takes a long time, as we'll discuss in the next episode. However, general relativity or special relativity, time for you would slow down. Could this be utilized to actually get there? And the answer is unfortunately no. And because mostly with special relativity, it has to do with your reference frames. So you're talking about Lorentz contraction and Lorentz time dilation and time contraction through the Lorentzian invariance. And through that, your time is still going to be experienced X amount. Now, time for either the people you're visiting or the people back on home, that's going to be different, but that's not going to help you get there any faster, unfortunately. Now, you can warp space-time. That's the general relativity aspect, where you can... Nothing says space-time itself can't go faster than the speed of light, and so that's how warp drives work. But that was a great question. A little left field, but no worries. I hope that answered it. All right. And yeah, some people were acknowledging that in the chat. And thank you. Thanks, Domestic. What patron level do I need to be on, and how many drinks do I have to buy to Science Timeline? I might just voluntarily. Science Timeline is one of our final... See, we're only going to be doing this for a couple more weeks, this specific chat. And so... we might throw Timeline in just for fun, because it's close to my heart. Anything with Billy Connolly. Glasgow Pride. It's gotta go in there. All right, so... Thank you, Alex. I'm glad you liked the explanation. Sorry, I'm going back in the chat here. Hoot Marut asked that they might be able to predict CMEs. That is true. We aren't able to predict CMEs now, but the new spacecraft that are observing the sun are helping us understand CMEs a lot better, coronal mass ejections much better, such that we may be able to predict them. Still, we're screwed, because if we see ones coming and we're about to... Earth's orbit is about to move into its path, there's literally nothing we can do. But, yeah. Also, hi, Science Streams. All right. Exactly. If you can see the blue light, you're already dead. Okay. So I think we're all caught up. Excellent. And hi, Uncle Bill. Walked in just in time. Yeah. The comedian. He's in Timeline. It's fabulous. It's so bad. It's so bad. It's just a wormhole. It's just a wormhole. And French history. And Billy Connolly. So, good times. All right. So. Oh yeah, Eyes of a Hunter. That's actually an excellent point. If we are able to predict CMEs, we could, in advance, put our satellites into safe mode. Shifting them to the other side of the Earth is probably too difficult, because they probably don't have enough fuel to actually do that orbital transition, and it takes a long time for those to move through. So, yeah, that would be a little bit difficult. And yay, a new sub. Appreciate it. That's very nice. And thank you, Domestic, for the support. I really appreciate it. And NC01. Do we call you NC Home? My binary is not what it used to be, so sorry. But anyway, thank you very much for the support. I appreciate that. All right, so last parts, because there's a bunch of new people here, and I really appreciate you all being here, and I love answering the questions, and this is awesome. But going back to window of opportunity, CMEs, I think we answered those. Solar flares, got that. The geomagnetism aspect, we don't have to get into it a bunch, but, the activity from the sun does affect our geomagnetism. Earth is a magnet, and that magnet comes from a rotating molten core in the Earth, and it generates a magnet. That magnet protects the Earth, and particularly our atmosphere, from solar wind and solar radiation. And when you do get a particularly high burst, that radiation that's coming from the sun, especially this magnetized material that's coming, will slightly distort the magnetic field. There is a balance, and it is ugly. It's very safe for us now, thankfully, because it's big. Our magnetic field is very big and does protect us, but it does get distorted. And two, in case you didn't know, the northern lights or southern lights, aurora borealis, is caused by charged particles from the sun hitting our magnetic field, getting spun up, and then following the magnetic lines and then hitting our atmosphere on the north and south poles. And so there's a correlation between solar activity and the ability to see the aurora borealis or the southern lights based on how much solar activity that is. So, good stuff. All right. Oh, and another thing, too, is that just talking about the, as Eyes of a Hunter mentioned, Hubble rotating. Same thing with the International Space Station, even though they're just in low Earth orbit, as is these other satellites. The International Space Station has an area that's more highly protected from radiation. It's insulated with water, and so if there is a high amount of solar activity, the astronauts are directed to move in there to just limit their radiation exposure, which is pretty sweet. Yeah, the world will end, but you get a good light show out of that. All right. Ooh, Asdelin, earworm alert. Okay. So anything left on that? We explained the subspace bubble, right? We got our subspace bubble that caught them in the time loop that was generated from the energy coming from the CMEs, the solar flares, and the geomagnetic field. I would say the geomagnetic field wasn't necessarily the source of energy, but it helped channel the energy that was coming from the sun to be utilized to build this subspace bubble. Thank you. I think that worked. That's the science from that. All right. So we're halfway through our stream. The next episode we're talking about is Stargate SG-1, Season 4, Episode 12, Tangent. But before we do that, part of our intermission is playing Spot the Star Trek, when we're not talking about Star Trek episodes, because we watch a lot of Star Trek here, for obvious reasons. When we don't talk about Star Trek, we have to find Star Trek references in the episodes that we're talking about. So Super DTG, because you suggested this, you can't throw it in yet. We have to give people time to answer. The clue I will give is there was a Star Trek reference in the next episode we're talking about, Season 4, Episode 12, Tangent. They did a very good one. If anyone caught it, who wasn't DTG because he suggested the episode, throw it in now. And we'll give it 10 seconds to answer it. Otherwise, Andy, go wild. So we'll do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nope. Nope. Aha! Almost real Retox. Andy, go for it. Yep. Who am I, Scotty? They said, we gotta beam me out of here. Beam me out? What am I, Scotty? Yay! Good job. Spot the Star Trek. We got that done. Awesome. All right, so the next episode, as we mentioned, is the episode Tangent. And this is where they get the... Like I said, my Stargate SG-1 lore is like 1% of what my Star Trek lore knowledge is. So, forgive me if I slip up. Feel free to throw in kind addendums as we talk about this. But, no worries, Andy. But please be nice. I do like Stargate. I'm in the process of like rewatching it and relearning this because I was a casual observer before and then became like a professional science consultant and just haven't gone back to watch Stargate yet all the way through. So we're working on that. There's not a quiz after, don't worry. Or unless you quiz me. Please don't quiz me. I obviously do very poorly in quizzes because I can't memorize anything for the life of me, particularly characters. Okay. All right. So, this is where they find they utilize the technology from the Death Glider ship, the X-301 is what they call it, that the technology will allow them to launch an attack against the Gould ship. If I say any of this wrong, I'm so sorry. one thing that I loved, I'm going to step through this kind of sequentially. Initially, they're just doing the test run of this ship. And Carter explains, it doesn't work on a traditional thrust-force relationship, which I really like. When we launch things, equal and opposite reactions. Newton, as Mass Effect taught us, the deadliest son of a bitch in the universe. We need an action-reaction to launch anything. F equals ma. If you want your mass to increase speed, if you want it to accelerate, you need a force behind it. So that force is typically fuel. That's our thrust. Thrust causes the mass to accelerate. That's how things work. Until now. As Carter points out, and as physics pointed out as well, this one runs on inertia. So what it does, runs on inertia. They said it takes inertia out of the equation. It utilizes inertia to accelerate. So what's inertia? Thank you for the exact quote. It kind of takes inertia out of the picture. So inertia is again, one of Newton's laws that a body at rest will stay at rest, or a body at motion will stay at motion, but no credit for partial answers. I've watched that Mass Effect clip so many times now, I'm like this close to having a memory. Unless acted on by an outside force. But that's like inherently what inertia is. Other ways of thinking about inertia is, it's why we wear seatbelts, because when we stop the car, our bodies want to keep moving. So we wear a seatbelt to slow that impact and to keep us from continuing to move. Another great example of inertia is when I was a physics professor, I had a lot of like real life applications of physics in your everyday life questions on my exams. And so one of them was explain what law of physics means you have to scrape the snow off of the top of your car. And there's a few laws of physics there, but one of them is, and if anyone's been in this situation when you were a teenager and were like, stupid parents, I don't need to scrape the snow off the top of my car. And then you start driving and your car heats up, creates a almost frictionless layer between the car and the packet of snow. When you stop, the snow keeps moving and lands on your windshield, and bad things happen from there. And that's inertia. So I'll always admit this, I am not sure how to science a starship that takes inertia out of the equation in order to move, to accelerate. Now, what they do say is that line runs right into where they say it kind of takes inertia out of the picture such that the pilots are immune to G-forces. That I'm perfectly fine with, because the G-forces is inertia. G-force is inertia. It's your body wanting to stay still as the thing is keeping you accelerating. So this reverse acceleration from inertia that your body is feeling is a G-force. And so taking inertia out of the equation would remove G-forces. But how you can... So we'll try. And I appreciate Andy to know my limits. We'll talk about inertial dampers in a second, but in order to actually accelerate a ship by removing inertia, so when you're accelerating the ship, you're using force to overcome the ship's desire, thank you, Renmoto, to stay in the same place. So if you remove the ship's inertia, or the ship's need to stay stationary, somehow... domestic. We're on the level of the improbability drive here. If you're somehow able to remove the inertial mass, the need for the spaceship to stay stationary, then you just go. You're not fighting anything, I guess, is the key. And the pilots don't feel anything. The problem is, which I don't know how to science because they didn't explain it enough, is that, how you would be able to do it. And we had a few people throw in inertial dampers, and I suppose inertial dampers are no more or less scientific than that. They're just saying, all right, we'll remove inertia from the equation. I have kind of scienced inertial dampers themselves within the ship itself. So it's this idea that you could have a layer of almost a reverse non-Newtonian fluid. Non-Newtonian fluids tend to solidify. At least they change their molecular structure when they have a high impact such that they appear solid. This is the oobleck cornstarch and water thing. And when you have a slow impact, it feels liquid. If you could do the reverse to create an inertial dampener such that you have a high impact, except it's like a liquid and it slows you down. It's like a reverse seatbelt almost that will keep you from feeling inertia too much. That's an inertial dampener. I mean, fundamentally, a seatbelt is an inertial dampener, so you can all have that one for free. That, engage the inertial dampeners means buckle your seatbelt, so you're welcome. But, all right, so, a couple things, and, yeah. Physics, you're welcome. That's what I was hoping. And yeah, space magic. I mean, that's kind of the level that we're at. Ooh, Asdelin, deep question. I like that. Would removing an object from the Higgs field solve that? Oh, geez, oh man. I think it would have much broader impacts than simply, because we're talking about just inertial mass, but it's inherent mass, and that's hard to overcome. Yeah, and just as Andy said, O'Neill's position, I don't care, just fly it. I mean, that's Stargate banter 101. I don't need to know how it works, so just let me do it. So, yeah. Eyes of a Hunter, can you generate gravity or anti-gravity with energy? Gravity, in theory, yes, because of E equals mc squared. So you can generate gravity by having a massive object on the fabric of space-time. But if you don't have that mass, you could use, in theory, an equivalent amount of energy to warp the space-time such that it appears to be the same amount of mass. Now, that all checks out in the math. We've never actually done that. Anti-gravity, that's not something we've ever necessarily discovered. It's kind of the principle behind tachyons, but those are theoretical particles, and because they invert space-time as opposed to dip it like normal gravity, they constantly move faster than the speed of light, so they're almost impossible to detect because we can't detect them. So yeah, good times. I like it. I like all the randomness. It's awesome. All right, so they test this ship that removes inertia from the equation such that it's able to accelerate incredibly quickly, and the pilots don't feel any G-forces, which I'm fine. That latter part, I'm fine with. Again, not super clear. Not super clear on the how it can actually propel itself, but within the ship, this idea of inertial dampeners is valid. Also, we should clarify for the people who are new here, because my background is in general relativity and space-time and explaining all of these things, how it all works, anytime I use the bowling ball on the trampoline analogy for space-time explanations has become a drinking game. So enjoy. That's where that's coming from. All right. So they take off on a test mission, and they essentially, they're like, all right, we're going to go fly it. And then it gets caught and it goes away. And everyone's like, ugh. And real retox. Typically we end up, I try not to intentionally throw those in there, but sometimes it's the only explanation I have. And it usually ends up being about 2 or 3 solid drinks during this. FYI. Yeah, it's fabulous. But they take off, and some of the cool aspects, some of the more military technobabble that we got here, and again, for those of you who aren't aware, between me being a astrophysics researcher and being a sci-fi consultant, I was an aerospace engineer, and so some of the details that they talk about in Stargate harken me back to that a lot more. So when they talk about the fact that like this craft isn't going to show up on the radar because of the technology that they have, so we installed a transmitter to be able to track it. Solid. Awesome with that. They've modified the warhead with a shield frequency modulator. I like that. That's more sci-fi. but this idea that, shields have a specific frequency, and if you're able to, you could penetrate a shield if you're able to modulate the frequency, or you're able to counteract it. All of that we've seen in science fiction. They didn't go into that much here, but, when they throw that out, I'm like, cool, that makes sense. And then they also talked about, like, when they take off and they head out into space, they said, all right, we have NASA looking for it, and we're utilizing DSP and NORAD data. Obviously Stargate takes place in Cheyenne Mountain, so that's pretty cool. And we have the DSP satellites. Those are the declassified reconnaissance satellites from the Air Force. So even the fact they threw in DSP, which, like, is impressive, especially for me, like, 15 years ago. But they said DSP and NORAD data. I was like, well, all right, cool. You do you, show. That works. It obviously makes me viscerally uncomfortable, so we won't go into more detail on that, but that was pretty sweet. And, thank you, Asdelin, for answering the Higgs field one. I was going to come back to that at the end, but I appreciate that. And Eyes of a Hunter. I'm going to come back to that inertia one. I'll carry on with this in a second, but, well, no, screw it. We'll just answer it now, because we're in the middle. Does it require there's gravity to make mass to have effect that with inertia? Right, so does inertia require gravity to be in effect, I guess, is how I'd interpret your question. I think that's correct. And the answer is no, not really, because inertia can also be not just the ability to, like, push something on the ground, but to also rotate something. So you have rotational inertia, which is how hard it is to rotate. If you've seen that before, it's typically what we do in, like, a Physics 101 class, where we'll set up different rods that have different diameters at the top of a plank, and then you let them go. And it's the ones with a smaller diameter start rolling faster because they have a lower rotational inertia. So, the fact that they're rolling downhill, that has to do with the gravity, but just the ability to get something to rotate, or get something to move, or get something to stop, that's not inherent to the gravity. So inertia is actually gravity independent. But that's a really, really good question. I appreciate that. And unfortunately, I mean, like most things in physics, we are using Earth as the reference point. So it's a little hard to isolate the two. But yeah. Oh, that's interesting. So on the atomic level, that has to do with different forces. So not talking so much about gravity, but more about the strong and weak nuclear forces. Yeah, it's a good question, Death Star Taco. Herding cats. Great question. I love it. Okay. So back to this episode. They're taking off at an extreme velocity. They say we're reaching an extreme velocity, but we're no longer accelerating. And this is really important here because we tend to forget this in space travel, particularly in science fiction, that when ships are going, they're just going at a fixed speed. If you don't have fuel, if you're not constantly burning fuel, you're just coasting at a fixed velocity. The reason that hurts our heads, and as viewers, when it comes to science fiction, we play with it a little bit more, is because we know that things will slow down if we're not pushing them further on Earth, because we have drag and we have atmosphere. But in space, we don't. And so if you reach a velocity, you're just going to keep booking it at that same one. Now, The Expanse does a really good job of utilizing that. I think The Expanse addresses it, is consistent with it, because their artificial gravity is inherent to the acceleration of the ship itself. So when they stop accelerating, they're still moving, but they're not increasing or decreasing their speed at 10 meters per second squared to have artificial gravity, and that's when they start floating. So The Expanse does a great, great job of handling that. All right, so they're at a fixed velocity, so they're not speeding up or slowing down, but they're basically the ancient one, or not the ancient one, the bad dudes are recalling their technology, so it's getting pulled toward them. and they're going 1 million miles per hour, which I always like when they call out numbers like this, where I'm like, 1 million miles per hour. I don't really work in the imperial system, and I'm used to like meters per second from physics and universal constants. So how much is that compared to the speed of light? And it's actually about 0.1%. So 0.001 times the speed of light, which is not insignificant. You would actually get a small but not insignificant special relativity effect, time dilation from that, which is pretty impressive. 1 million miles per hour. Thank you, physics. I appreciate it. Apophis. That's the bad one, right? Thanks. Yeah, they're booking it. They're going really, really fast. But even then, because space is very big, and I do like that Stargate is consistent with this, it will take them several hundred years to just traditionally go through space here and get to their destiny, where they're being pulled back from. One thing I really like in this episode as well is that they did a great job of showing the time lag of conversation. Great job. That is so hard to pull off in science fiction. That is so hard. The fact that they are like 3 minutes and then the minutes are increasing as they're further away. They were 3 minutes. They're much further by the time they're out at Jupiter. That they, they'll say something and then time will pass. They're saying something back. And then as they're saying their stuff back to Earth, the, message from Earth is appearing. So you feel that frustration and that time delay. And again, that is so hard to convey in real time in a sci-fi show. So I think they did a great job with this, because even in things like The Martian, where they try to bake that in as well, you still don't necessarily have the sense of how long it's taking to communicate. They're just saying explicitly, okay, we sent our message, now we wait. And they wait and they get their message back. It's not this frantic sort of back and forth where messages are coming in and out of order. And I think that's brilliant, really, really good. So way off on the time. I tried to math it, but the issue is that we didn't know where. Yeah, so physics and Andy asking, and Real Retox mentioning what the transmission lag was. The issue is we don't know where they all are in their orbit. All we know is that they're going to pass Jupiter, and we don't know if. So let's imagine that they basically were at the shortest arrival point. Even then, it's not straight. So if we have our orbits, Earth and Jupiter. If you want to travel here, by the time you get there, Jupiter's like over there. If you're trying to reach it when you're here, you can kind of, but Earth's also moving. So it's kind of this like football type pass that you have to do. So it's not a direct clear shot. And then even then they weren't totally explicit with exactly how much time it was taking this stuff. So if we have any, if I didn't catch any, the most I got was it's going to take at least 3 minutes. We weren't necessarily able to measure, but I might have missed it. So if they did mention in the episode a specific number of minutes beyond the 3 minute thing, because 3 minutes, that's nothing. That's super close. So if it stayed consistent at 3 minutes, then yeah, that would be wrong, because Jupiter is much further than 3 light minutes away from us. We are 8 light minutes away from the sun. Mars is 12 light minutes, so even if its closest point, that's 4 minutes between Earth and Mars. And then Jupiter, how many? I'm just going to look it up. How many light minutes is Jupiter? All right. 43 minutes. 43 minutes? If that came in right. That's a lot. Yeah, thank you, Real Retox. You get the prize. Well done. Well remembered. Yep, 43 minutes. Good job. Round of applause. That was fabulous. Well remembered. So yeah, for us, 8 minutes, 43 minutes. That's a long period of time. And I think that's much, but it's hard to tell from the show. exactly how much time was passing because we're shortcutting time and everything there. But I gotta say, regardless of exactly if they got the minutes right, the ability to convey the delay in messages was done really well for being a fast-paced episode. It was done really, really well. No worries. And so super impressive there how they were able to pull that off. Great thing too, sort of the last major science point from this episode that I really liked was that they were going to try to slingshot them around Jupiter. They saw that they were reaching Jupiter. They were gonna do basically a flyby, a close flyby of Jupiter, and they thought, okay, we can turn them around, get them flying back home by doing a gravitational slingshot. Always happy when gravitational slingshots show up. But they needed a slight nudge. And so they're sitting there, and then he looks down at his mission, at his missiles. And of course, even when I'm watching it, I'm like, woo, physics! Because that he's going to use the thrust from the missiles to nudge the ship. All they needed was a nudge to get it into the gravitational well to do a slingshot. And it was brilliant, the way that they did it. I love, too, the way that they showed it, where they got one, so it nudged the ship this way. Then it fired both, so it was actually just accelerating towards the gravitational well. And then they fired them as one final thrust. Now, it did not work as planned. So, sucks on that one, but that's more story-driven than science-driven. And the way that they were doing the science to drive the ship into the gravitational well for a slingshot was awesome. So, loved that. All right. And let me see. Yep, missiles were awesome. And yeah, the trajectory, I have that chart of cosmic exploration that, Andy, I don't know if you want to find and throw in the chat, that shows the slingshot paths that every single spacecraft that we've sent out into the solar system has taken. Is pretty impressive. It's not just Cassini. They've taken almost everything we send does these slingshot motions, so it was pretty impressive. Ryuk, yeah, those thrusts would have to be super accurate, and there was a little back and forth. I think they were trying to convey that it had to be very accurate, but didn't want to explicitly say what it was because of us, or people like us, to just not, let's not give them an actual number to play with. They just need to, because he did, remember, they sent them the message, and what I did like is that they were time-stamping their audio messages saying when they sent them, and they said, you're going to have to do this at what was like 1643 Zulu or something, and we sent this at 1641, or, they received it at 1641. Pulled those numbers out, but you get it. And then they were getting the information of exactly how they needed to do it as they were going. So, yeah, there's the link to the cosmic exploration one, and it's awesome. Yeah, just give it a nudge. It's fine. And, all right. Anywho, yeah, it's really cool. As Andy says, that was one thing where I was like, I have it in my house, and I mentioned that. He was like, hey, I have that in my house too. So yeah, pretty cool. Oh, domestic. I have so many thoughts on time slips and multiverses. I'll mention that at the end. And yeah, any last things here? They use the term delta V correctly. A delta V just means a change in velocity, to use the Greek triangle as your delta. And V means change in velocity. So that's aerospace engineering as well as a physics term. But the delta V we want to get out of the missiles. That was a nice detail there. And yeah, then we got our Spot the Star Trek. Beam me out. What am I, Scotty? And that's kind of the major physics stuff from that episode. Obviously, they have like the ring transporters and the communication devices and all of that, but that's more of the science, space, magic stuff that we love. And oh yeah, physics. Thank you. They had hypoxia as well. That they were completely oxygen deprived. They eventually passed out, and then the trying to communicate with them, trying to get them to wake up, what little oxygen was still in their environment. Yeah, that was good. Thank you. That was a good catch on that one. I appreciate that. And yeah, they were trying to wrap their heads around everything there. So good times. Oh, thank you for the host. We have T-minus 0 minutes left. But Anyway, with that, so just to kind of close things out, Domestic mentioned thoughts on time slips and multiverses. I have a lot of thoughts on multiverses. Thanks for the follow, Thomas, and physics. I appreciate it. Yeah, so these multiverse theory, I've got a lot. And in fact, I mean, not to kind of totally self-promote, but I have a, thank you, Cranston. I have a Audible original series called The Science of Sci-Fi that is just under 4 hours long, and there's a whole chapter on multiverse theory and the way that those work, because there's lots of different kinds. I also have some videos, a little bit dated now. It's a little bit, oh, baby Aaron. They're like 3 years old when I was just getting started doing this stuff. But I have a 2-part YouTube series that is part of my Dr. Aaron Explains the Universe, which you can find the link to YouTube down below. I have a 2-part YouTube video on multiverse theory as well that pulled a lot from for that Science of Sci-Fi, so you can definitely check that out. And it's fun. There's lots of cool, really interesting, different kinds of multiverses. So it depends on which one you're talking about. Physics. There's a lot of different ones from time travel to, this bubble to infinite, and what does infinite mean, and all of this sort of stuff too. Thank you. And thank you, Billy. I appreciate that. So there's the link in there. That's to the audio series, and then my YouTube link is down below too. And for those of you who came in late, if you didn't hear the announcement, I made an announcement today regarding my Patreon page. So Patreon page and my Twitch streams are changing up a little bit starting next month. We're going to be retiring this episode club. I love it, but we have done a lot of sci-fi episodes. And so I appreciate all of the discussions that we've had. It's been really fun. I think my intention is just it's not going to be as structured as this, because it ended up taking up a lot of my time to go through and watch these episodes and science them. And I'm pivoting a little bit more towards behind the scenes work with the work that I've been doing with Star Trek and all of that. So I'm trying to make more time in my schedule to focus on that, as much as I love doing this. But I'm not disappearing, so please don't worry about that. I'm still going to be streaming. In fact, you might actually see my face more because I'm still going to be doing my Mass Effect Monday streams. I'm still teaching Astronomy 101. I'm still doing my Star Trek Sunday stuff. So none of that is disappearing. And then any of these sort of conversations are just going to be more random one-off ones, not every single week. So I appreciate all of your understandings. You can find more information here if you're curious about that. But I really want to thank every single one of you, the new people, the people who've been around for a while and supporting all of this stuff. And you're welcome, Mappa. Thanks for staying up to midnight. And thank you all. And I'm glad we did Stargate. So thanks to Super DTG Andy for the suggestion there. And Andrew, yeah, but you're still gonna see my face. And if as we discuss things, interact on Twitter, if we ever want to do just a random one-off, hey, I saw this episode, I'm obsessed with, I really want to learn about it, let's hop on our live stream and let's talk about this X episode, I'm more than happy to do that. So that is never going to completely disappear. And I do really appreciate the support. So thank you all. I think so I will put up some to vote on for next week. Oh, GM for life, thank you. I am going to put up some to vote on for next week for the patrons, but the last week, we never got around to it. I'm going to Science Avenue 5. So if you haven't seen that, even just do a trial subscription of HBO or something, just go watch Avenue 5, and we are going to do... We're just going to do it. I don't want to spoil anything too much in case you haven't seen it, but it's going to be really, really, really fun. So that will be the last Tuesday, not next week, but the week after that in August. And yes, thank you all. Uncle Bill, anyone else who missed the beginning of this, no worries. I've recorded it. I'll be putting it up on YouTube shortly. And it does demand my attention. So thank you all. I really appreciate everything done here. Let's go say hi to Extra Credits. They're just playing Minecraft. So I'm going to send you all over there. We're going to raid Extra Credits. If you haven't done a raid before, you don't need to do anything. I'm just going to pop you in there, say Dr. Aaron sent you. If you have channel points, you can, grab one of my emotes, my Dr. Aaron cheer emote, if you want to pop those in there. But anyways, I appreciate... we'll send you on a Stargate mission. That's it. Tell them you went through a Stargate and you're saying hi. So anyway, thank you again. I really appreciate all the love and support. Stand up, stretch, get some water, and I will send you to extra credits now and definitely tell them I say hi. Tell them you popped through a Stargate. I love it. All right, guys. Thank you all so much. I really appreciate it. Live long and prosper. All right. Till next time.